All right, welcome to the video of testing for parallelograms. In the last set of notes, 6.2, we talked about the several different properties that make a parallelogram. So we're going to go back over those in just a moment, but first for our warm-up. Now, this may be a little tricky for some of you guys to do on your own, so it'll definitely help you walk through it. We're only dealing with sides on this parallelogram because it says given the parallelogram A, B, C, D, going back over how to name it, A, B, C, D, they went clockwise starting with A. We're going to find the values of x and y. Well, since the two properties we dealt with the sides is opposite sides are congruent and also that opposite sides are parallel. The parallel aspect usually helps us with our alternate interior angles or sometimes same side interior angles. Well, with this one, we're dealing with congruency. So here we're going to see that segment AD is congruent to segment BC. Segment AB is congruent to segment DC. Well, if you look at that, we can't set these together. We can't set just these together to solve for x and y. So we're going to use our system equations. We have not done this a lot, but we do need to start kicking this in and making sure that we're understanding. So we're going to use, like the previous notes, I was encouraging my students to also write down what property we're using. So we're going to use that our OPP opposite sides are congruent. And knowing that, what we're going to do is we're going to set this 4x plus 8y equal to 24. And we're going to use the negative 4x minus 2y equal to 12. And we're going to go ahead and we're going to add these two together to find out that, look at this, our x's are going to cancel out. And we're going to wind up with 8y minus 2y gives us 6y. And we are adding these. 24 plus 12 is going to give us 36. When we divide by that 6 to solve for y, we're going to find out that y equals 6. Look at that, we just found y. So now to find x, we could take either one of these two equations, plug in for y to solve for x. I'm going to take the one without the negative 4x, and I'm just going to go ahead and say, all right, with the 4x plus 8y equals 24, I'm going to remove y, and I'm going to plug in what we solved y to be, which was 6. This in terms will give us 4x plus 48 is equal to 24. And now we just, bam, 2 steps. Solve for that x, subtract the 48, and then divide by 4. We will wind up with a negative x, and that is okay. X being negative is perfectly fine, but when we plug in to find the actual length, which we already know is, when we plug in for this one we just did, plug in for x, we should get 24. Distances and lengths are always going to be positive, but the x can be negative. If you plug that negative 6 into here, you will wind up with a positive 24. Now review what we talked about with our properties of quadrilaterals. Not only do we have our parallelograms, or two properties of quadrilaterals, 4 sides, all angles up to 360 degrees. We have that opposite sides are parallel. If you want to highlight, you can. Both pair of opposite sides are congruent, so we have our congruency marks. Opposite angles are congruent, so here we go. Our diagonals are bisecting each other, so here are congruent markings there. Say they are bisected, cut in half. And then that last one we drew in on our notes because it was not there, is that one pair of opposite sides is both congruent and parallel. If we see any of these, don't need all of them, guys, we only need one of these, we can say it is a parallelogram. So let's take a look at the first problem underneath this category, shall we? We're looking at, can we conclude the quadrilateral with one pair of opposite sides is parallel and the other pair of opposite sides is congruent? Is it a parallelogram? So let's draw what we're talking about here. Let's draw in quadrilateral. What we're talking about here is that we have one pair of opposite sides congruent, the other pair being parallel. Can we prove that this is a parallelogram? Well, if we use our parallel lines, or parallel sides here, and we draw in our transversal, we will have alternate interior angles. So we draw these in as our alternate interior, okay? We have to use those two because these two sides don't exist when looking at parallel lines and transversals. If I take these two sides away, there are the three lines we have. The two parallel with the transversal. Well, I guess you can use the other ones, but, well, no, you can't because this guy right here doesn't exist. All right, so you have to use these two. What we have here is we need to go back to our triangle congruency chapter. We look at this, we're going to end up, if you look at one single triangle, okay, we have here that this side will be congruent. That's what I call the shared sides or reflexive side. So we're going to wind up with side-side angle. And we talked about SSA is spelling a bad word backwards. So we cannot use that as a congruency postulate. So here, this is why we talked about one pair being both parallel and congruent. Having one pair parallel, the other congruent does not work because of this concept. So we'll put in here no. We'll just put no rather than spell everything out. No. Let me, hold on 1 second. We'll try to reword it. It forms SSA. This is not congruent, okay? I decided to word it differently than I did in the original notes. A little bit shorter. All right, so let's take these properties and let's determine if these are going to be parallel, if these quadrilaterals are parallelograms. The first one we're seeing here that we have 5 centimeters and 5 centimeters opposite of each other. So that means these are congruent. If we look at the other two sides, we have 12 centimeters and 12 centimeters. So we have another pair. So we can say, yes, this is a parallelogram, and we're going to write in which property. Both pairs of opposite sides are congruent. And there's your abbreviation. If you need to write it out in words, please. Both pairs of opposite sides are congruent. On B, we see here that we have a pair of opposite sides congruent and we have a pair of opposite angles congruent. But if you look back at our properties, we need both pairs of opposite sides congruent, and we don't. We need both pairs of opposite angles are congruent, and we don't. Or you can have that consecutive angles are supplementary, but we don't know what this angle is here. So we cannot conclude that this is going to be a parallelogram. We have only one pair of opposite sides congruent and only one pair of opposite angles congruent. Okay. Now, we are going to be told that, basically we're told that these are parallelograms. We want to find the values that would make this quadrilateral a parallelogram. So we're going to take a look at number 3A. We're seeing these angles. We either have consecutive angles being supplementary or opposite angles being congruent. In my opinion, the opposite angles congruent kind of makes a little bit easier for me. So here I'm going to use opposite angles congruent to solve for both x and y. To solve for x, here we have 7x and we have 56. So just 7x equals 56. And we divide that out, we're going to get that x is equal to 8. We look at the 4y plus 4 being congruent to the 5y minus 26. Set them equal to each other. I want you to go ahead and pause the video and solve on your own. The answer is about to pop up, so please pause the video, solve for y on your own. And here is your answer. Make sure that you got 30. All right, on B, we're looking at the sides. So what do we know about the sides of parallelograms? Opposite sides are congruent. Opposite sides are also parallel. We're not dealing with any sort of alternate interior or same side interior angles, so we will be dealing with our opposite sides being congruent. So we'll go ahead and mark those markings in so that we see why did we do this when we look back at it. And we'll use OPP, opposite sides congruent. So I want you to go ahead and pause on your own. We're going to do the exact same thing we just did with the angles. We're going to set opposite sides equal to each other and solve. For x, we will have 3x plus 4 equals 5x minus 2. For y, we will be using the 4y minus 9 equals 2y plus 5. Please pause the video. Both answers are going to pop up. You need to be practicing solving for x on your own. I'm going to give you a second. Go ahead and pause the video, please. All right, and this is what you should have gotten, 3 and 7. Now the next page, we're going to have to delve back into chapter 1 and deal with slope formula, midpoint formula, distance formula. These are 3 ways when we're dealing with the graphs. What we want to do is we don't have to use all 3 of these. The reason I have all 3 of these on here is to show you each way you choose which one you want. Okay. First thing we're going to do is we're going to go ahead and graph points A, B, C, and D on the graph and connect the points for me. Make sure that you label them. Go ahead and do that now. Pause the video, please. All right. Now, slope formula. We need to remember that your slope formula is going to be y2 minus y1 over x2 minus x1. What I'm going to do first is I'm going to find the slope of, so what we're looking here is, do we have opposite sides being parallel? We need to remember that parallel lines have the exact same slope. So if segment AB right here and segment DC have the same slope, they are parallel. Then if segment AD and segment BC have their same slope, they are parallel also. So let's go ahead and take a look at segment AB and segment DC. So here we're going to find the slope of segment AB. This is a subscript of segment AB, letting you know that that's just what we call a little subscript, so you know which one we're looking at. I'm going to take take A and B. I'm going to do y2 minus y1, so 2 minus 3, over x2, 8, minus x1, 3. And we're going to find out that this is going to wind up being a negative 1/5 slope. Then let's take a look at the slope of its opposite side, DC, or CD, whichever way you want to name it. When we find this slope, looking at points C and D, we're going to have y2 minus y1. Remember, it's a minus a negative. We're going to have x2 minus x1. And this is going to wind up with a negative 1/5 slope as well. So these right here are going to be parallel. Guys, you cannot stop here. Say, oh yeah, okay. Do not trust your eyes either. You need to actually figure out what is the slope of the other 2 opposite sides. So here, let's take a look at slope of segment AD. So we look at the points A and D. We're looking at y2 minus y1, 0 minus 3, over x2 minus x1, 1 minus 3. Apologize. Get my numbers mixed around. When we do this, we're going to find out that we have a positive 3/2 slope. Now its opposite side, the slope of BC, over here. All right, B and C, y2 minus y1, I'm saying 2 and writing 2. y2, negative 1, minus y1, 2. Got a little confusing there. x2, 6 minus x1, 8. When we put this in the calculator, if you don't put it in the calculator, then you do it by hand, you're going to wind up, well, no, you won't have to. It'll simplify automatically. We're going to wind up with positive 3/2 as well. So this is also parallel. So using our opposite, this one right here, opposite sides parallel, that's what your slope formula is going to do. okay? You don't have to use slope. If you'd like to, let's look at the midpoint formula, okay? And I'm not gonna be able to show the points up here whenever we plug in for x1, y1, etc., but make sure that you're looking back up at the top for that one. Here, we're gonna go ahead and midpoint formula. So this is an uppercase M. This is gonna be parentheses x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So you're going to have coordinates here. With the midpoint formula, what we're doing is we're finding out if the diagonals bisect each other, okay? So what we're doing here is we're now going to look at going from AC to from DB. So I'm going to go ahead and draw that in here. We're going to find out if they have the exact same midpoint. If the midpoint of AC and the midpoint of BD, they have the exact same coordinates, you have them bisected automatically, okay? So let's take a look at first the midpoint of segment AC right here. So we're going to use coordinates A and C. So I'm going to put MDPT for midpoint of segment AC. My students know I call it the midpoint. And we'll take x1 plus x2, which would end up being 3 plus 6, divided by 2. y1 plus y2, which would be 3 plus a negative 1 divided by 2. When we put these in our calculator separately to come up with an x coordinate, we will get 4.5, and our y coordinate will be a 1. Let's take a look at the midpoint of the other diagonal, segment BD. Right, plug in our formula. We'll have 8 plus 1 over 2, and we'll have 2 plus 0 over 2, all coming out to 4.5 for the x coordinate and 1 for the y. Now, we already knew that this was a parallelogram because we found the slope formula, but again, I need to show you each and every way. So this right here, we do have the midpoint being the exact same for both diagonals, meaning they bisect each other. And right here, we'll put in there intersect at same midpoint, meaning the diagonals, and I'll put diags, are bisected. Okay, that's the way you prove diagonals are bisected. Distance formula. A lot of us don't use the distance formula because it's so lengthy in so many different ways you can mess up by putting numbers in it, but I'm obviously going to show you that. What we're doing here is trying to prove that opposite sides are congruent. If the distance from A to B is the exact same as the distance from D to C, that means those segments are congruent. Those sides are congruent. Same thing with AD and BC. Both of them come out. We already know it's going to, right? But in this case, we still need to use that distance formula. Remember, you cannot count on the graph the distance from AB. You can't go, okay, 1, 2, 3, 4. It does not work that way. You have to use either Pythagorean theorem, which is where we get the distance formula from, or just plug into the distance formula. Here with your distance formula, we'll go ahead and write out that distance formula real quick. Which is the square root of a number, or you can plug, if you plug everything into the calculator at once, you'll get a decimal. So I will be kind of presenting both of those ways here. A lot of us will plug it all into the calculator one time and get a number, which can be very dangerous. But let's go ahead and take a look at, first we're going to look at the distance between AB and then the distance between DC and compare those. They should be congruent because we already know that it is a parallelogram. So the distance of AB, if we plug everything into our formula, we're going to have x2 minus x1, which will be 8 minus 3 squared, plus y2 minus y1, 2 minus 3 squared. Plugging this in, leaving it as a non-simplified radical, we will have the square root of 26, or if you plug it into the calculator with the square root, you're going to get 5.1. Now let's take a look at the distance of the length of CD. Okay, the opposite side. We're going to go ahead and plug that in real quick. X2 minus x1 will be 1 minus 5 squared. Y2 minus y1 will be 0 minus a negative 1. Careful with that negative. This will also come up with the square root of 26. Again, we already knew they should because we are already dealing with the parallelogram. So here we could say, yep, these two are congruent. And we'll take a look at AD. So now we're going to technically the left and the right sides here. Length of AD, plugging into your distance formula. X2 minus X1, 1 minus 3 squared, plus Y2 minus Y1 will be 0 minus 3 squared. This is going to cut, now it should, and we'll talk about later, if it ends up coming out to the same thing, square root of 26, we'll talk later about what other kind of quadrilateral it can be. But in this case, just talk about a parallelogram without those other properties of the rhombus and the square. We're just looking at, now this one is going to come out to the square root of 13. It's okay that it doesn't come out to the square root of 26. We're just looking at parallelogram. When you take this into a decimal, if you plugged everything into the calculator, you should have gotten 3.6. Again, this is just rounded to the nearest tenth. Now let's take a look at BC. This should be the square root of 13 or 3.6 as well. X2 minus X1, 6 minus 8 squared, plus Y2 minus Y1, negative 1 minus 2 squared. And this does come out to the square root of 13 or 3.6. So these are going to be congruent also. So your distance formula is to prove that opposite sides are congruent. Okay, so we've got 3 different ways of proving these parallelograms. These are parallelograms. With the slope formula, one of the easiest ones, of course I did not say this at the beginning, but I will let you know the little secret now. If you have the graph from A to B, down 1, run 5, negative 1/5. From D to C, down 1, run 5. You don't always have the graph provided for you though, so that's why you need to know the formula as well. So this is it for proving parallelograms. If you have any questions, you can search YouTube for other channels, or please ask your teacher, or please rewind and repeat.